Alright, for section 4.6 we are now graphing cosecants and secants and tangents and so on. And so I'm going to do two like I did in 4.5 to help you out. I'm going to graph one cosecant function and one secant function. And I'm going to go ahead and suggest that we'll start with this first one. I'm going to go ahead and suggest that again you look at what I call the new x-axis number. I see that this graph is going to get moved up 2, so my x-axis is really going to be here. And then from there the amplitude is -1, so it's going to go 1 above and 1 below that. So I know that my graph is going to be somewhere between 1 and 3, or at least that's where my original sine graph would be. So I want to make sure I at least cover that. Alright, so now when we're graphing, it's kind of like when you're working with sine, cosine, tangent, and then you're working with cosecant, secant, or cotangent. Anytime you're given one of the three that you're not familiar with, or at least as much, the cosecant, secant, and tangent, think about what we did. Like if I gave you this problem and I said, I want you to find the secant of 60 degrees, you know, what did we think to do right away? We said, well, okay, yeah, I know we want 60 degrees, but I'm going to find the cosine of 60 degrees, which I know is 1/2, and then I'll just take the reciprocal of it. So it's 2. So I always thought in terms of cosine, and then I switched it to secant after I knew what the cosine's answer was, or if it was cosecant, I figured out what the sine was and then reversed it and so on. I'm going to do the same thing when I graph it. I'm actually going to look at this and say, okay, I definitely see it says cosecant, but I'm going to ignore that, and I'm just going to replace it with sine. And I'm going to pretend to graph the sine. Now I'm doing that to help me figure out what the cosecant is going to look like we did in class. Alright, I noticed that my b value does not have pi on it, so you probably noticed that I've labeled my x-axis with pi radians. And now I'm going to do the same thing I did when I graphed the sine and cosine. I'm going to do all the same information. I'm going to start by looking at the new x-axis, which I see is 2. So I'm going to lightly put a line here at y equals 2. There's my new x-axis. I'm going to set the parenthesis equal to 0 and solve it to get the new y-axis. This is a little bit quicker and easier to do for this one. It looks like x is equal to 3 pi over 2. So here's 1, 2, 3 pi over 2 is right here. So there's my new y-axis. So now I pretend that that particular point is my origin, and now I can ignore basically those numbers. And then I'm going to find the period, and for this one, really nice, because our b value is 1. So our period is 2 pi, which remember we want the steps, which means I divide that by 4, which is going to give me pi over 2. Which basically means I'm moving pi over 2 to the right. In other words, I'm moving 1 tick mark here. So I'll move 1 tick mark to the right, and then I'll put my next point. Alright, I've got all my information. I can now just start graphing it. I look at the actual trig function. It's sine, so I know I should be going through this pretend origin. So I'm going to put a point here. According to this, I move 1 tick mark to the right, and then I'm going to start by going 1 tick mark down. So 1 tick mark to the right, down 1 tick mark. There's my next point. 1 tick mark to the right, back to your pretend x-axis. 1 to the right, up 1, back to your x-axis. Down 1, back to your x-axis. Up 1. So it's actually exactly the same thing that we did yesterday when we were graphing, which makes this hopefully a little bit easier. You're probably saying, well, this is almost the exact same thing. How is this cosecant when we're graphing a sine function? All we're going to do is graph the sine function to kind of help us see what's going to happen. Now I'm going to actually graph the sine function, but I'm going to do it very, very lightly. So when you draw this in, please do it lightly. You want to be able to see it, but kind of just barely. And hopefully you do a little bit better at hitting all your points than I did. Alright, and if you remember in class, why is it that I want to see this? Well, the reason I want to see the sine or the cosine or whatever the trig function is that I graphed lightly in here is I want to see where does it cross my pretend x-axis, because wherever that happens, that means I have asymptotes there. So that means I have an asymptote right here, 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 and of course everywhere it crosses my x-axis. So there are all my asymptotes. So again, you are looking to see where does it cross your x-axis. And then the other thing you want is all of the little max and mins on the trig function that you graphed, those are actually the points or the vertices of these little parabolas that open opposite directions. So that point is going to open up. This one will open down, up, and just of course rotates every other one down, up, and while I'm making these darker, this is what the actual graph looks like. We discussed kind of how we know it does this. Now that we know it does that, all you're going to do is graph in the original trig function, find where it crosses your x-axis so you can get your asymptotes in the right spot, and then use those max and mins on that trig function to put in your parabolas. Alright, there's the first one. Second one, basically same information, it's nothing really different. Only thing I look at this one is I see that this is secant, so when I start to graph this I'm going to think of cosine instead. But other than that, again pay attention, -4, and I need to go 2 units above it, 2 units below it. So when I'm down here at -4, I'm going to be going up to -2, down to -6, so you can see I've kind of made the negative y-axis a little bit longer because I knew that was going to happen. Alright, I look at my b value. There's no pi on it, that's why I do have pi integers on my, that's why I'm using pi radians on my x-axis. And I'll run through and do the same steps that we've done for all the graphing problems. My new x-axis is at -4, so y equals -4 is the line I want to draw in. There's my pretend x-axis. If I set the parentheses equal to 0 and solve it, it's going to help me figure out where my new y-axis is. And so I'm going to subtract pi, multiply both sides by 2, and -2 pi is where my pretend y-axis is. So that point is like my origin now. So now I can disregard basically all of those numbers, go ahead and find the period, and I take 2 pi divided by b, which in this case b is 1/2, so I divide by 1/2 or multiply by the reciprocal, I get 4 pi. And again I'm going to divide that number by 4 to see how far my step is, and my step is pi, which means I need to go 2 tick marks before I put the next point down. And now I'm ready to start graphing. Alright, here's my origin. I can see that the function is cosine, so I should not be starting at the origin. I should be starting at, since the amplitude is +2, I should be starting 2 units above it. So I'm going to be starting right here. And now according to my step it says to move pi units to the right, so go 2 tick marks, go back to your x-axis, 2 tick marks to the right, go 2 units below your x-axis, 2 tick marks to the right, back to your x-axis, 2 to the right, 2 above it, back to your x-axis, 2 units below it, and just follow that pattern until you have your graph kind of filled out. And then again, lightly draw in these curves, as this is not really part of the graph. This is just going to help us get it. If you had paid attention, you would see that the b value is less than 1, so I should have expected this to be stretched out horizontally, and it definitely is. Alright, I look to see where does it cross my x-axis. Well, it looks like it crosses my pretend x-axis here, so there's my asymptote, or one of them. There's another one. Here's a third. Here's a fourth. And now just go ahead and put your curves in. There is going to be one vertice of one of the curves I've got. Use the asymptotes to kind of help shape it. There it is. And then please make this part darker. Like when you look at this graph, you can definitely see that those little curves, those parabola-shaped objects, those are the darkest part of my graph. This is just in there lightly to help me. I actually do want you to draw that in there. Some people will just leave it out because it's not really part of the graph, and that's okay, but I prefer to actually see it. It's easier for me to look at this graph and identify if you've got all the characteristics that you're supposed to. Alright, hopefully that helps you with your homework in 4.6. If not, feel free to come in and ask for help.